The sides of a right triangle having lengths of 6, 8, and 10. We're going to find the measure of the angles to the nearest tenth. All right, so once again, we've got this right triangle with lengths 6, 8, 10. 6 and 8 are the legs, 10 is the hypotenuse. We're going to look for the measures of the angles to the nearest tenth. All right, so there are 3 of them. Let's take a look at this. First of all, this one down here in the corner at C is easy. It's a right angle. It's a right triangle. So that one's easy. Angle C, the measure of C equals 90 degrees. Oh, hey, problem of the day done. No, only kidding. We're finished. No, we've got one of them. Now we need to go for these other 2 guys, which obviously are acute, because these 2 little angles add up to, they add up to 90 degrees. We've used up 90 degrees out of 180. So we have something and something that's going to be both acute, that's going to add up to 90. The question is, what are they? So let's put some numbers on this thing. I'm going to put the 6 because it looks smaller there on AC, all right. I'm going to put the 8 down here on BC. And then over here on segment AB, the hypotenuse, always the longest, we're going to put 10. Now the question is, what's going on here? And you know, some of you are going like, are there some magical formulas? Well, there sort of are. We've got to go to the trig functions, the trigonometric ratios, all right? And that, my friends, is where we get a little bit more fun here, all right? So I can use 3 possibilities. Let me go through them real quickly. There's the sine of angle. I'm going to start with B since I marked it, okay? The sine of B, angle B. You could also do the cosine of that angle B. And there's another little friend called the tangent. This is most of our right triangle trig. Now there's also 3 other functions, but these are all we need to look at. And since our problem of the day gave us 3 situations, 3 links here, we can use any of these. We're going to do all 3 of them just to make sure you understand that, hey, you get the same answer if we work it right. So here's where we're going to start. We're going to first start with sine of angle B, and that's equal to the opposite over hypotenuse, all right? So it's the opposite leg over the hypotenuse. By the way, this is for you geometry and also some of you pre-calculus students who are getting into these things, into your trig units at this point. A lot of you on the block are doing trig right now in pre-cal, and many of you are getting there also with your geometry. So there's very timely problems here. So let's see where we are. We're at opposite leg, which, by the way, opposite means all the way across. See where that's going? All the way, that's 6. And here we go. The hypotenuse is 10. Now, if we were to play with the cosine, here, let me pull a little arrow down here, we would be talking about the adjacent leg. Now, 6 is a leg, 8 is a leg, 10 is the hypotenuse no matter what, all right? So we're going to look at the adjacent, which, by the way, I'll spell it ADJ, a little short motion there, over the hypotenuse, and that's going to give us 8 over 10, all right? Because there's the adjacent leg, there's your hypotenuse, 10. So if we were looking at this, we would say, how about it? 6/10, 8/10, or we could just do as we have. We could just use 6 over 10 and 8 over 10. Now tangent, while we're at it, since you're wondering, are you going to do it too? Yeah, we will. It's going to be the opposite leg over our adjacent leg. And that, dear friends, is going to be 6 over 8, which comes out to 75/100 or 3/4. By the way, these could be 3/5, 4/5, but I kept them in tenths and decimal form. It really doesn't matter as long as we've got the equivalent fraction or decimal there. Now, what are we going to do with those? Here's the story. What we're going to do, if I get a little more room down here at the bottom, I'm just going to work off the sine. I'm going to go back to our sine formula here. It says sine of B, and sometimes we leave off the angle B just to make it a little bit easier. It's not always has to be there. Equaling to 6/10, or 0.6, or 6/10, or 3/5. All of those are equivalent fractions. You get my idea. Now, what I want to do is, how do I get to angle B? How do I get to angle B? And what we've got to do is we've got to write it like this. We've got to take the sine of the inverse of 6/10 is equal to the measure of angle B. Wow, that's like an undoing. But that is what we're doing, all right? We're going to say the sine inverse. So let's use the calculator because you're going, Mr. Ernie, how in the world do we do that? Well, it's an inverse problem. So let's go to the calculator. I'm going to point out to you. Get me over there, folks. Can we get to the calculator? Hi, ladies. And let's see. Can we get to the calculator? Here we go. We are going to look at the second inverse. By the way, notice where my arrow is trying to cursor. It's to the second. And I'm going to go down here at sine. I'm going to hit the sine, all right? That's how we get sine -1 with the parenthesis, all right? That's called sine inverse. And it looks like a little -1, but that means inverse. So again, we hit the second, hit the sine button, and then type our fraction, or in this case, we could type our decimal. I'm going to go ahead and use 6 divided by 10. We'll close it, and we're going to hit enter. Now, that tells me degrees right there. That tells me how many degrees we've got. So the measure of angle B looks to be, we'll take it to the nearest tenth, it said, looks to be about 36.9 degrees, all right? That's our first storyline, all right? Well, now we've got C, we've got B. You say, well, Ernie, what if we've done the cosine? Well, let's check it out. Let's go back to the calculator. I'm going to leave what we've got up here, and let's go with second cosine. We're going to do the inverse of the cosine. Also gives us a little practice hitting that second button in the word cosine. And this time it's 8 divided by 10. It's a different value. Use the function you've got there. So let's see what happens if we do that one. We'll close the parenthesis for good measure. We will close the parenthesis for good measure. There it goes. And we'll press enter. My goodness, it gave us the exact same thing, even out to, wow, 8 decimal places. 8, count them, 1, 2, 3, 4, 5, 6, 7, 8 decimal places. And it could go on and on. This rambles along. And of course, you wonder, well, does tangent work also? Let's try it. Two different numbers. We have what? 3 over 4, 6 over 8, or 0.75. Y'all want to see how the decimal works? Sure, let's do the decimal on it. Tangent inverse. Let's put a point and a 75 hundredths for us there. Close it. And let's see if we get the same value. We do. All right. Now, I want to give you one little pointer here, and don't take the calculator away from me yet. The big thing you got to make sure when you're doing these problems, somebody said, I didn't get what you got. I got this crazy decimal. All right. Go to the mode, and you need to have degree highlighted. If you don't have degree, you can cursor down, 1, 2, and then cut over there. Don't have radian, but hit degree, press enter, and life will be good, and then redo your problem, and it should give you the degrees that I was getting, all right? Now, that's, let me clear that stuff out there, and there's where we were. And again, each time we got the same degree measure, so it looks like 36.9 or 36 9/10 to the nearest tenth. That's what the question asked us for. That's angle B. So now one more shot here. We'll use the calculator. Remember I said angle B and angle A add up to 90. So let's take 90. We shall subtract. How about it? We shall subtract 36.9, 36 9/10. And we will get the other angle, which is 53 1/10. So the measure of angle A equals 90 degrees minus 36 9/10, which will give us, as we said here, 53 1/10 degree. All right. So that's our story here. So if we can go back to my paper here we go. We got it right there. There's our final solution to get to angle A. And now we got angle B rocking there. And of course, hey, it's a right angle. To the nearest tenth, it's 90 degrees. All right.
For more math help, visit TNLearn.org.